What is the solution to this differential equation? So first of all, you need to know that this is a first order differential equation. Now, what is a first order differential equation? Why did I call it that name? Now, if you have let's say dy dx as the expression of the differential of a particular function, then this would actually be a derivative or a differential of the first order. It becomes an equation if you equated it to some value, maybe 0 or any value at all, right? So this is actually a first order. You could have it as dy dx, or you could have it as dz dx, basically whatever. You may have it as dt d theta. Now what this basically means is you have a function y and you are actually differentiating that function with respect to x. On this other side, the function is z and you are basically differentiating it with respect to x. Here you have t, which might be any function at all, and you are basically differentiating it with respect to theta. So that is a first order differential source. It might not be an equation, but you should just basically know that this is a first order because you just have the first form of its derivative. You could also have a second form, and that would now be a second order. So if you had that differential equated to 0, then you clearly have a differential equation right there. Okay, so for second order, we should have something like this: d squared y dx squared, and here for z, that is going to be d squared z dx squared, and here you should have d squared t and d theta squared. This is basically a second order differential form. We might not say it is an equation yet because we don't have equal to 0 or any other form right here. So this is basically just a form, okay? But this is an equation. Now, since we have that this is just the first differential or derivative of the functions, this basically will be a first order differential equation. So that is why we called it that. So let us see the main form of a differential equation. So a differential equation is basically of this form. You have phi into x, comma y, comma dy dx. Now this is in a case where you have not actually differentiated, but in this case you have differentiated it in the first form or the first case. You could also differentiate it a second time, and that is basically going to give you d squared y dx squared. You could also have it as a d cube y and d, that is with respect to dx cube. So that continues to whichever form or power or order that you actually differentiated that expression or function with respect to. So I might just write it as d of n, or d raised to the n of y. This should not be an x. This is supposed to be a y. So dx of n. Okay. So this is supposed to be equal to 0. Now this is a differential equation because these forms are actually equated to a number or at least something. So we know that this is a differential equation. So if you have such a form of expression or equation and you are actually asked to find the solution to that, then that means it can only be solved if you are able to reduce it or resolve it into this form. So if you are able to resolve it into this form such that you would have a function in terms of y dy plus f of x dx, and this is equal to 0. If you can change such a differential equation into this form, then it will be possible for you to find a solution to that. And that is basically by integrating both, or I should rather say all the terms within that expression. So that is basically it. So that is the task that we have over here. We need to rearrange this differential equation into this form. Now, if we are able to do that, We basically just need to integrate it after that, and that will give us the answer to the question that we are looking for. So let us jump right into it. Now, we have this form. First off, you know that we need to take every variable which is not in terms of the other to the other side or to the other term. So this is where there is a dy. Now we're going to take every expression or term which is basically in form of y and take it to where dy is. So the only way to do that is to divide through by what we have there. So I'm going to divide through by 2y minus 3. So this is also going to be divided by 2y minus 3. Now over here, we're also going to have a 2y minus 3. Now of course, I know that this could get cancelled out, but we're not done just yet. So we know that we want to take every form of y away from this and bring it to this other side, which is basically achieved by doing this division through each of the terms. But over here, we have x squared plus 1, which is not actually a function or an expression in terms of y. So we want to take it away from here. And so that is going to be divided by x squared plus 1. So since I'm doing that, that is basically going to get done over each part of this equation. So this is what we have. Now 2y minus 3, this is going to get cancelled, and you have a x squared plus 1 cancelling. Now over here, we know that 0 divided by anything, that is basically going to give us a 0. So there is basically not going to be any change right there. So that is now going to be x. This will be divided by x squared plus 1. You have dx here. And over here, we have a dy divided by 2y minus 3. This is equal to 0. So as you can see, we have the forms in the correct order that we wanted them to be, which is f of x dx and f of y dy. And this is equal to 0. Now that we have changed this into this sort of form, we can now actually find the solution to the expression. That will be basically by finding the integral of each term within this equation. So let us try to do that. So I need to integrate this. So this is going to be dy. And this is integral 0. So how can we integrate this? Basically, we need to use the form of integration by parts. Whoa, that should not be by parts. I should actually rather have said by u substitution. So we're going to use the substitution method to find the integral of this. If you are not actually very familiar with the method of substitution, I have actually uploaded a video on my channel, so feel free to go check it out. So this is going to be, so first off, I'm going to make x squared plus 1 to be u. So let u be equal to x squared plus 1. So that is going to be, so du is going to be 2x dx. Now this should come off easy because we know that du dx should be 2x plus 0 because the derivative of a constant is basically 0. Now if I took dx and multiplied it through, that is going to be du, and it will be equal to 2x multiplied by dx. Now I basically want to change this and make dx the subject of the formula. So what is that going to give? That is going to give dx being equal to du divided by 2x. So that is what we have there. Now basically I need to use this and plug it back into the expression. So I'm just going to wipe out this. So this is going to be integral x over u, and this is multiplied by dx. So dx in this case has been changed to du divided by 2x. And this is plus integral. So I'm just going to change this and make it to be 1 over 2y minus 3. And you have dy there. This is going to be integral 0. So this should actually come off more easy now, because I would actually cancel x with with the other x which is on top there. So this gives us 1 over u multiplied by 1 over 2, and that is du there, plus integral 1 over 2y minus 3 dy, and this is integral 0. So since we know this is actually a constant, we're actually going to take it out. And so this should actually be a coefficient of the integral. So this is 1 over u multiplied by du. And this is going to be 1 over 2y minus 3 dy. And here we have integral 0. Yeah. So that is what we have. Now the next thing we need to do, we need to integrate it right away. So what is going to be the integral of 1 over u? Basically, that is going to give us ln absolute u. This is going to give us ln absolute 2y minus 3. And over here, we have the integral of 0. So that is a constant. Now, you should know that integral is also called as an antiderivative. So that should basically be the antiderivative of a constant. If I differentiated a constant, that should give me 0. So if I took 0 and integrated it, it should take me back to the constant. So that is the reason why the derivative, or rather the integral of 0, is a constant. Now finally, we know what u is. So we said u is x squared plus 1. So I just need to rewrite this and replace it with what that is supposed to be there. So that is going to be ln, and we would have x squared plus 1. Over here we have ln 2y minus 3. And this is equal to constant. So this will be the answer to the question. So let us try another one. Okay, so let us say that you are given 2xy, root 2xy rather, multiplied by dy dx, and this equal to 1. So what is going to be the answer? Feel free to pause the video and try that by yourself. So I'm going to change this into its other form. But before I do that, by sorts, I know that this should change to root 2 multiplied by root x multiplied by root y. And so this is equal to 1. Now I'm going to change this into its initial form. So this will be x raised to the power of 1 over 2. And here we have it multiplied by y raised to the power of 1 over 2. This is going to be dy dx, which is equal to 1. Now next up, I need to take everything which is not in terms of x, well, I should rather say which is not in terms of y, and take it to the other side. So first off, I'm going to use dx and multiply to this other side. Now you should know that I could actually have done that over here already. That was just a misstep, but it doesn't really make any difference. So this is the same thing. Now I'm going to have x raised to the power of 1 over 2. And here we have y raised to the power of 1 over 2. This is dy. Now if I multiply dx by 1, that is going to give me 1 dx. Now finally, I need to take x raised to the power of 1 over 2 to the other side. So that will give us root 2 multiplied by y raised to the power of half by dy. And here I'm going to have x raised to the power of 1 over 2, and we're going to have dx right there. Now, for this one, which is actually a constant, I basically don't need to take it anywhere because it will actually not make any difference. So there is actually no need for taking it any other place than where it is. So this expression could be rewritten this way. We could actually have it as a root 2 multiplied by y raised to the power of 1 over 2 multiplied by dy. And I could rewrite 1 over x to the half as x raised to the power of 1 over 2, and this will be dx. So this is actually a very good form because I could actually take it exactly head on and find the integral of it. But before I do that, I would actually make it to be more resemblant to what we have here. This is actually supposed to be f of y dy plus f of x dx. And that should be equal to 0. So what that means is I need to take this and bring it to the other side, basically. So that is going to be root 2 y raised to the power of half dy. This is minus x raised to the power of negative 1 over 2 dx. And of course, this is going to be equal to 0. So as it is, we need to find the integral of each term within this equation. So let us try to do that. So that is going to be 2, and we have y raised to the power of 1 over 2 dy. This is minus integral x raised to the power of negative half dx. This will be integral 0. So this is basically going to be, this is a coefficient, so that won't change anything. But we need to work on this one. So that is going to be x squared. And we would have y raised to the power of 1 over 2 plus 1 divided by 1 over 2 plus 1. This is minus x raised to the power of negative 1 over 2 plus 1 divided by negative 1 over 2 plus 1. This is on this side, we're going to have a constant. Okay. So this gives us 3 over 2. So that is going to be root 2 multiplied by y raised to the power of 3 over 2 divided by 3 over 2. Now here we're going to have x raised to the power of, this is going to be negative 1 over 2 plus 1. What does that give us? So that gives us 1 over 2. This is divided by 1 over 2. This is equal to constant. Yeah. Now we know that this can actually get taken up and this also. So we should actually have something like this. Root 2 multiplied by 2 y raised to the power of 3 halves This is divided by 3. And here we have 2 multiplied by x raised to the power of 1 over 2. And this is equal to a constant. Now basically this should be divided by 1. So even if we have it divided by 1, that basically doesn't make any difference. So you might not really need to write it there. So this is going to give us root 2 multiplied by 2 over 3. Cool. So that should be 2 root 2 over 3. This is y raised to the power of 3 over 2. This is minus 2 root x. Because x half, sorry, that should be x raised to the power of half. If you have that, that is the same thing as root x. So this is equal to a constant. So this is the solution to this problem. Now we have some more. Let us try out some more. So let's say that you were given this. dy dx is equal to x, y minus y. What is going to be the solution to this differential equation? Now, of course, basically I'm going to take this and multiply through this side. So that is going to be x, y minus y. And I'm going to have dx there. Now, I could factor out y from here. So that will be y. Now, xy divided by y, that is going to give me x. Now, we have y divided by y, so that is 1. Now, I have x with dx over here, which is actually homogeneous for the x variable. Now, I need to take y to the other side so that we may have a homogeneity for y. So that is basically going to be division. So I should have a 1 over y, and this will be dy. Now over here, this will be x minus 1 dx. And the next thing I need to do, I need to take this and bring it to the left so that we would have a 0 on the right hand side. Now this is 1 over y dy minus, this is going to be x minus 1 dx. This is a 0. So I need to integrate this. So that is going to be integral 1 over y dy integral x minus 1. We have dx, and this is integral 0. So basically this what is this supposed to give us? So this is supposed to give us ln y. Now if we wanted to do this, basically we need to integrate each of these terms. So I'm just going to do it this way. This is going to be integral x dx plus, because we're going to have minus multiplied by another minus. So that gives us a positive. Integral 1 dx. Integral 0. So this is ln y minus integral x dx. That should be x squared over 2. And the integral of 1, that should give us x. And over this side, we basically have a constant. So that will be the answer, basically, for this question. And let us try out another one. So what will be the solution to this expression? So first off, we need to bring it out and make it more homogeneous. That is going to be f of x dx plus f of y dy, and everything equal to 0. So that is first off what I need to do. Now we already have cosine x here, and I would actually not bother myself bringing cosine x to the left hand side. I will just leave it here for now. So I need to take this to the other side and take dx to the other side. So first off, let me use this and multiply to this side. So this will be sine x over 1 plus y multiplied by dy. This would give us a cos x dx. Now next up, I need to eliminate this from the left and bring it to the right. So how am I going to do that? Basically, I could just take 1 over sine x and multiply it to both sides. So that will be sine x over 1 plus y dy multiplied by 1 over sine x. And on this other side, I will have this multiplied by 1 over sine x. So this will cancel this out, and we will basically have 1 over 1 plus y multiplied by dy. Then here we are going to have a cos x over sine x. That will be multiplied by dx. So the next thing I need to do, I need to take this term and bring it to the left. So that will be 1 over 1 plus y dy. This is minus cos x over sine x. And this is dx. So this is going to be equal to 0. So this is particularly what I need to integrate. So let us try doing it. Now, this is going to be integral 1 over 1 plus y dy. Here we have integral cos x over sine x dx. Then over here we have integral 0. So what is the integral of 1 over 1 plus y dy? So that basically should give us a 1. Sorry, that should be ln 1 plus y. Now this, how can we solve this? So we need to use the method of u substitution. So before I do this one, let me just evaluate that. So let's say u is equal to sine x. So du, that will be equal to cos x dx, right? Now we already know that there is a cos x dx here, so I will replace that with a du. So I'm gonna have 1 over 1 plus y dy, and over here I will have a cos x over u. So this should actually be replaced with a du because we have a cos x dx. And this was actually to be replaced with a du. So this is going to be a du. And over here we have integral 0. So what is the integral of 1 over 1 plus y? So that is going to be ln 1 plus y. And here we're going to have a minus ln absolute u. And over this side, we're going to have a constant. Now we know what u is already. U is sine x. So I need to replace that with sine x. So this is the answer to this question. That will be the solution of this differential equation. Now let us try out one last question. So here we have cos squared x dy dx is equal to y plus 3. We need to find the solutions to it. So as usual, first thing I'm going to do, I would actually take dx and multiply to this other side. So that is going to be cos squared x dy. And this is going to be y plus 3 multiplied by dx. Now, as you can see, we do not have homogeneity here yet. So I need to take this expression and bring it to the other side and take this one to the other side. So that is going to be divided by y plus 3. And here we are going to have a cos 2x. Whoa, that should be cos squared x. So over here I have a y plus 3 cos squared x also. So this cancels this out, and here we have y plus 3 getting cancelled out. So this is going to be y plus 3 dy. So we have this homogeneous, and here we have a 1 over cos squared x dx. Okay. Now, what is the reciprocal of cos squared x? Now we know that 1 over cos x, that is actually secant x. So if we have 1 over cos squared x, that should be secant squared x. So what that means is 1 over y plus 3 dy is the same thing, or is equal to sec squared x dx. So this is what we need to integrate. But before we do that, let's just bring sec squared x to the left hand side. So that will be 1 over y plus 3 dy. This will be minus secant squared x dx, and this is equal to 0. So I need to integrate both, or I should rather say each term within the expression or the equation. So that will be 1 over y plus 3 dy. This is integral secant squared x dx, and this is integral 0. So what is the integral of 1 over y plus 3? That is going to be ln y plus 3. Now here we have the integral of secant squared. Now, because we know that integral is antiderivative, we could actually go backwards. Which trigonometric identity or ratio actually will give you secant squared x if you differentiated it? Now, we know that if you differentiated tan x, that should give you secant squared x. So if we took secant squared x and integrated it, that will take us back to tan x. So as it is, the integral of sec squared x, that is equal to tan x. So this is going to be tan x, and over here we're going to have a constant. So this is the answer to the question.